Welcome to GitMap. We're gonna do Titanic classification. It is binary classification. It is a really simple data set, and even who are not advanced in the data scientists can try to do it, to run the model and get the results. The good thing about Titanic dataset is that it has both continuous and categorical variables, and it is pretty well-known dataset. If you look for the Titanic classification, you will find like maybe 100 codes on the Kaggle, on the GitHub. We try to clean it up and provide the best for you. So be with us, and we will start just going through the code and explaining it. Titanic is a simple example and a simple data set, but still you can make it a little bit more general by applying all of the machine learning models that you know. So about the Titanic, it is, if you have already seen the movie, it is about the passengers on the Titanic, and then we are trying to predict which passengers are going to survive and which one are going to die based on the information, the data that we have about the passengers. So this project is specifically making a prediction on Titanic, and we start by importing the libraries, as you can see here. So the dataset that we have, and it is publicly available dataset, we have two set of the data, train and test. We're gonna learn model using the training data and then predict the survival on the test set. And using train.head, you can get some overview about the columns, about the type of the variables. So, and then here I brought like the simple explanation about each variables. For example, survived, which is the target variable, and we have yes or no. And then P class, which is ticket class, as you know from the movie, the higher class has poor people, and the lower class is where we have the rich people. And then siblings, parent, childhood, ticket number, cabin, embark, which is port of the embarkation, which has 3 categories. And then from the columns and the naming, you would see that passenger ID is basically just the ID that is assigned to each passenger. It doesn't mean anything. It doesn't transfer any information. It's not going to help model to learn anything. So we're gonna get rid of that. On the other side also, we have the ticket number, which is just a random number assigned to the tickets. It is not also meaningful, so we're gonna get rid of that as well. For the others, we can see that the name is long string, and then we have sex, which is categorical, and age, which is continuous value, and then siblings, which are parents, childhood, nominal values. So the good thing is that we have combination of different type of the variables here, and then we're gonna deal with them. If you look at the cabin, you would see that we have null values here. We need to take care of this either by removing this column or any column that has NaN values, or by imputing this NaN values, meaning that we're gonna replace them with some values. Okay, let's start with missing values. We need to handle them before doing any modeling. And here I brought the percentage of missing values for each column. And you would see that, for example, for the age, we have 20% of that missing, 77% of the cabin variable is missing, and 0.22% of the embarked is missing. We're gonna either impute them or, as I said, remove them. For the cabin, consider that, at least based on my research, when one variable has more than like 50% values missing that column, if we impute it, it's gonna be more random rather than the actual values, and it's not gonna teach the model anything. So we're gonna remove this variable. Just assume that a variable with more like 80% missing values, if we impute it, it's not going to help the model to learn. So that is the basic idea, but you can do your own research and get with the idea about the threshold that you would like in order to remove the variable or either impute it. And then here we have again just the count of the missing values for each column. You would see that for the age we have 177, for the cabin we have more than 500, and then for embarked we have only 2 values missing, which from the exploratory data analysis we're gonna figure out a best way in order to impute them. Okay, just using train.shape and any dataset.shape we can get the dimension of the dataset. So here we have 891 rows, 12 columns, and for the test we have 418 rows and 11 columns. And then using .columns.values we can get all of the columns from the dataset in order to just make sure we have all of the columns listed. And train.info gives us the type of the variables and the count of them. We can see that we have all types of the variables, most of the type of variables like integer, float, object, and we need to consider them differently. Using train.describe we can get the statistics of the data set, and by adding this parameter include equals all we can get the statistics of all of the columns, and we need this in order to get overview of the statistics of our data set. And for example, from like this table we can consider different categories for age. If we want to categorize age, we can consider that the 25% of the data the age is 20, and for 50% it is 28, for 70% it is 38. So we can categorize age up until 80 in 4 different categories. So this could give us some information about like the counts, frequency, average, and also 25% and half of the data, 75% of the data, how the variables looks like in those ranges. And then we started plotting. One suggestion is that whenever you want to plot the data set, please make sure that you consider the target variable versus the other variables that you are trying to plot. For example, here we plot the survived versus the age, and we can see that the curve is more toward the left. And if we consider just up until 50 age, we can see that it is close to normal distribution. And this could give you some idea about how you're gonna handle the outliers, if you're gonna remove them, or if it's not gonna help your model, you can just keep it as it is. And then here you can see that I just considered the categorical variables. Please make sure that you handle categorical variables in the best way. They are really meaningful, they're gonna help the model. And here we can get the count and unique numbers and also frequency for each variables. And then using the heat map you can get the correlation between variables. So here, for example, you would see that fair and survived has positive correlation. On the other side, P class and survived has negative correlation, which from sorting them you would see that for the P class, which is the ticket class, if we have like the lowest P class, we're gonna have higher survival compared to the other side. If we have higher P class, we're gonna have lower survival, because as we increase the P class, as I explained at the first, the poor people are located on the higher P class and the rich people are located in lower P class, which makes sense from our understanding of the data and the models, the charts, sorry. Okay, here again it is more visualization to do exploratory data analysis, and you would see that we charted survived versus the P class. Again, you would see that as lower P class we have higher survival compared to the others, and the bar chart also is transparent in this regard. And then we charted the sexuality versus the survived to just see which one has higher survival compared to the others, we would see that like the male has more death compared to the female, or vice versa. We can see that female has higher survival compared to the men. And then the number of the siblings versus the survived, again the number of the parent childhood versus the survived, and each of them you can interpret them, and we have this code complete in the GitHub. You can just go there and one by one run the code and see the actual plotting and results. Okay, and then again the embark. So I tried to plot each of the variables versus the survive to just see how they are affecting the survive. So for example, here we would see that the S category has more deaths compared to the other categories, and which might be helpful when you are interpreting the variables, but for here I don't see any explanation for that. This is just the general information. And then we saw that the P class is important in survival. On the other side, we saw that like the male has more deaths compared to the female. So one interesting thing would be to visualize these two variables versus the survived, which is the plot that I have here. Using the factor plot, we plotted three variables versus each other, and we can see that for lower P class, we are expecting the higher death, and female has lower death compared to the male. However, as we go forward to the P class, we have higher P class, then the number of the females who are survived is getting lower, which means that as we have higher P class, higher number of the female die. Okay, those are some conclusions about the charting, some understanding of the data. Now we're gonna move on to preparing data for modeling. So from the value.counts, we can get the counts of the each classes. So we have 549 for the non-survived and 342 for the survived. And then we can see that the number of the people who has died is not like the number of the people who has survived is not twice as number of the people who have died, which means that we don't have imbalanced class. And here I brought explanation of the degree of the imbalance. We would see that the extreme happens when the smaller class is less than 1% of the whole data set. The moderate happens when a smaller class is just 20% of the data set, 1 to 20%. And then the mild is when a smaller class is 20 up until 40% of the data set. And here it is, the small class is about like 40%, but I don't consider it imbalance, so I didn't deal with the imbalance handling. You can try it. I didn't see, at least from my research, it's gonna affect the model because, as I said, this data set is not imbalanced, highly imbalanced. But you are welcome to try it out. We're gonna try it out on different data set, the fraud detection. You can try it out here and see if it affects. But based on our experience, it didn't. So, and then on the test set, I added one column to just make sure that we're gonna assign the prediction to this column and have prediction for the passengers that we don't know if they're gonna survive or not. And then one more thing is that for the name, we see that we already took care of the cabin. We gonna get rid of this. And then for the name, it is long string. We need to take care of it. You see that these are just the random names, which are not meaningful. But on the other side, we have Mr. Mrs., which might be helpful because we have Mr. and Mrs. and all of the others. We can have 3 categories to just make sure these are basically including all of the categories that we have. So here, using the regular expression, I tried to exclude the prefix for Mrs., Mr., and so on to just see what kind of the categories we have. And then here I tried to change the name to the title and just keep the title from the name category, and then fill in the embark, and then fill in the fare based on the P class. So these are some ways in order to fill out the missing values, and on the other side clean up the variables and change them with the meaningful one. Okay, and now we had also missing values on the age. If you remember and you look at it again, the best way in order to handle the age is just to get the average and standard deviation and create some random values inside that category. The same we did for the test in order to fill out those missing values. And now that we are done with missing values, the next thing is take care of the categorical variables. All right. So for categorical variables, as I explained at the first, we have embarked and we have sex, which has two values, two categories. We're gonna get dummies of those categorical variables. And why we do that? Because these are the categories, and if we replace them with some random numbers like 1, 2, 3, then 2 gonna have higher weight compared to the 1, and 3 gonna have higher weight compared to the 2. We don't want to misbehave the model, so the model just misunderstands that there is higher weight in one sexuality compared to the other, which in actual real world there is not such a thing. So in order to make sure the model considers them separately, we're gonna create the dummy variable, which it's gonna look like this. You will see that here we still have this. We're gonna get rid of this part, this column. We now created this female, male, and CQS for the impact, which you can see here. And one more thing is that each step that you are doing on the train in order to deal with the variables, with the features, you're gonna do the same on the test set. Because we're gonna also modify the test set in terms of cleaning it up and finally making the prediction on those pre-processed data. Okay, after we created the dummy variables, now we're gonna do the same for the name. As you remember, we extracted some categories from the name. Now we need to create dummy variables for that. And then also for the fare, we created some categories based on our descriptive statistical analysis. And the same for the age. You would see that here I have 5 categories, and these are basically extracted from those statistics, and then created basically the dummy variables for those ranges. And eventually you would see that these are the dummy variables, and we got rid of those old variables and that we replaced with the new dummy variables. And finally the cleaned up data set for train looks like this, and for the test looks like this. For the test, I already kept the passenger ID to just make sure we're gonna assign basically the survival to this data set. That's why I kept this. But when I create the X and Y for train and the actual test, I will get rid of this, which I will show you here. Okay. Here is where I started creating the dataset, preparing it for modeling. We have X train, X test, Y train, Y test. We're gonna train the model using this on the X train and also Y train, which is basically the labels. And then we're gonna test that on X test and compare the prediction with the Y test, which hopefully it's gonna make sense for you, based on our pictures that we have uploaded on Instagram about the supervised and unsupervised learning. This is the simple classical example of supervised learning. Okay, As I said, there are different ways of imputing the missing values. Here I considered removing the column because it had more missing values, and also using the mean standard deviation to impute the missing values. It was better in terms of the accuracy compared to using mice. So what does mice do is that it uses the k-nearest neighbor in order to fill out the missing values, which is used for continuous variables. And I didn't use that here because some of the pages have used this, but compared to using the standard deviation and average, we got better results. So that's why I kept that and commented this out. So you can try it by yourself and see the result, compare them in case if you liked it. But these are all pre-processed data. So this is the actual data that we have after doing all pre-processing and preparing data for modeling. After getting this, you would see that I tried different base classifiers using xtrain, xtest, and using cross-validation. So we have used cross-validation to make sure our result is generalizable. You're gonna get the same result if you run the model, or maybe close, like maybe 0.81%, but it shouldn't be more than that. The variation should be there, but it shouldn't be high because we are using cross-validation in order to test our model. And then KNN, SVM, and multi-layer perceptron, decision tree. And these are some base models that we tried from different type in order to get the base idea about how our model is working on our training data set. And then we did the same for the ensemble learners, which the popular ensemble learners are random forest and then gradient boosting, maybe the AdaBoost. There are lots of the ensemble learners. If you go to in one of the Instagram videos, I brought a lot of the libraries in different type of the classifiers. But here we just bring some, maybe here just 5 or 6 base classifier. Each of them behaves differently. If you get a good result, for example, in decision tree, you need to focus on this, on different type of the decision tree in order to make sure you can improve your model. You don't need to focus on other types. That's why we brought different type here to make sure that you get the base for different type of the classifiers. And then you would see that after tuning the hyperparameters for these classifiers, we get better result from the extra gradient boost. That's why we kept it here. And then we used that in order to get the parameters and make the prediction using cross-validation. And this is the best score so far. I got like 0.82, 0.83. It's gonna be between that with that standard deviation, and then use that in order to make prediction and then assign it to the test set. Finally, we submitted it as a submission.csv file. You can check it out on the GitHub and it is all documented. And that's all about Titanic classification. Hopefully this is gonna give you the basic idea about how we're gonna utilize different classifier, get results, and get basically the understanding about how your base classifier is working on simple data set. This is not tricky data set. This is just gonna let you learn about the basics, and with the classic data set, which is a good data set, I would say. It didn't have really a lot of missing values, really imbalance, which you're gonna see in real world, but this gives you a good basic idea and basic understandings of supervised learning and working with the classifiers. All right, thank you for being with us, and wait for the next video. Bye.